This video provides material from the following two publications.
Is inertia a conventional force? Can it be assigned to one of nature's four basic interactions, like possibly the gravitational? If action exactly equals reaction, shouldn't a pushed object retain its motional status? Today's theory does not explain how inertia functions. According to Einstein's principle of equivalence, the acceleration force applied on a passenger of a rocket, accelerating at g, feels the same as the force of gravity, applied on a person standing on Earth. The force felt in the rocket is apparently the inertial force. But while the inertial and gravitational forces may feel the same, does this imply that these two forces are also of same nature? The new model addresses why this is not the case, as they have very different origin, as well as different essence. Gravity is an action force, while inertia is not exactly a force. It corresponds to an impeding potential. This is very much like the electromotive force in electronics is also a potential, not a force, as it is measured in units of volt, not in Newton. Let's see how this arises for the case of inertia. According to what was described in video 2, the fastness in the flow of time reaches zero value at nodal regions, where time halts. At the surface of a black hole, and at the distant outer universe. Beyond which points, time is predicted to take negative values, as shall be elaborated upon later, in video 6. But if that holds for time curvature, should it be same for space curvature? Existing quantitative analysis predicts a specific surface outside a black hole. At either side of this surface, interactions are predicted to point in opposite directions. For example, outside of this surface the centrifugal force points outwards, as it should, while inside this surface it is strangely predicted to point inwards. And angular stresses inside this surface are also predicted to transfer in the opposite direction. The Tsikuta's model interprets this place as a space node. In this way, the time and space curvatures are subject to a phase shift between them. This shift is not arbitrary, and shall be shown to arise through a very symmetric process to that of an inductive phase shift in electronics. Its existence is responsible for causing the inertial behavior of matter, in a very similar way to as a shift between oscillations of voltage and current in electronics causes impedance in the operation of electric engines. Due to this phase shift, the energy spent in accelerating an object is split into a real and an imaginary coordinate. In this case, only the real coordinate of energy does work in accelerating an object. The imaginary coordinate does not do any work, since its corresponding energy is not utilized. This results to an inefficiency to accelerate, and that is what we perceive as inertia. In this respect, inertia corresponds to an impeding potential, much like its electromotive counterpart does. Notice a point of importance. In the electronic case, an inductive phase shift between the oscillations of voltage and current develops in time. While instead, in the gravitational case, the inductive-like phase shift between the curvatures of time and space is developed over space. The introduction of this particular swapping between parameters of time and space is of significance, as it allows to bridge quantitatively the gravitational and electromagnetic interactions. Here, it allows to associate inertia to the gravitational interaction through relations of gravitomotive form, in deep analogy to ones of the electromotive case. The new model additionally introduces certain critical concepts. First, the shift in space applies over the whole cosmic scale. In this simplified illustration, from a black hole all the way to the outer universe. This inductive-like shift in space is introduced to directly refer to the Higgs field that permeates spacetime, as we shall elaborate upon in the next video. Second, in the ordinary case, the inertial reaction coordinate is less effective than the larger action coordinate. This is why an object may accelerate at all. Therefore, the statement that action equals reaction is inaccurate, since action and reaction are not of the same essence. A third critical point that the new theory introduces here is that, since the curvatures of time and space are distinct to each other, the gravitational field could not assign to the curvatures of both of them. Space and time curvatures are understood to correlate tightly to each other, very much like voltage and current oscillations are tightly correlated in electronics. In fact, we shall later figure that there exists a particular reason for the deep symmetry between these two cases, which shall appear once we present certain new concepts concerning the electric field, in Video 8. According to what is to follow, gravity directly assigns to time curvature, while space curvature has a complementary role that shall be presented to have large implications in both particle physics and astrophysics.